Hello, everyone. Welcome to PyData Global. We're excited to have you join us. Feel free to use the chat to connect with fellow attendees and share your thoughts during the session. If you have any questions, please put them in the Q&A tab and we'll address them at the right point in the presentation. But it's my pleasure to now introduce Matthew Powers. He will be presenting his talk, New Features in Apache Spark 4.0. So with that, let's give a warm welcome to Matthew.
Hello, everybody. Thank you so much for having me. Can you see my screen and hear me all right?
Yep, looking good.
Perfect. Let's dive in. Okay, so in this talk, we are chatting about the new features in Spark 4. Spark 4 is coming out probably early next year, and it has a bunch of cool new features. So we're not going to have time to talk about all the new features, but we'll just kind of dig into these features. So specifically, the Python custom data sources, the ANSI mode, which is going to make your Spark SQL much safer, the variant data type, which is going to make it much faster when you're operating on JSON-like data, Spark Connect, which opens up the Spark ecosystem to a bunch of different programming languages, converting to Arrow, which is going to make Spark more interoperable with other engines. And then I kind of snuck in a couple of 3.5 features just because they're so cool. So specifically the parameterized queries, the Python user-defined table functions, and hyperlog log sketches, which are amazing, especially for cohort building and the like. Let's dive in. So let's take a look at these Python custom data sources. And in this case, we're going to look at how to import Hugging Face data sets easily into Spark data frames. Just for convenience sake, I've used Databricks in this example, but that's not necessary. And we, of course, don't have to use Hugging Face. We're just using this as an example. So let's explain this problem set a little bit. So there's a lot of custom data sources in the world, and you want to easily import them into a Spark data frame, but you don't want to kind of define all that business logic every time. So with the Python custom data sources, you can define a class that will explain to Spark how these Python data sources should be imported into a Spark data frame. And then you can turn your attention to section 2 there, and you can see that you can register these data sets. So in this case, we have defined this class, Hugging Face datasets. We have defined this custom dataset, and then we've registered it with spark.datasource.register, and we'd register the Hugging Face datasets. And then once that is registered, when you turn your attention to section 3 there, you can see you can run spark.read.format Hugging Face.load Rotten Tomatoes, and we can easily import one of these Hugging Face datasets into a Spark data frame with just one line of code. So this is a really great tool to use in an organization with lots of custom datasets. So they can kind of just define these custom data sources in one place, and then like your downstream users, let's say your data scientists, can just load them as if they're native datasets to Spark. Okay, let's take a look at ANSI mode. So ANSI mode is available in earlier versions of Spark, not just 4.0. But in Spark 4.0, ANSI mode is going to be enabled by default. So when ANSI mode is enabled, Spark SQL is much safer. And when ANSI mode is off, Spark SQL can behave in dangerous ways. So let's take a look at some of these dangerous ways that Spark can behave. So let's take a look at integer overflow, for example. So let's suppose we have a Spark data frame with 2 columns, letter and number, and it just has 3 rows of data. And we can see in that number column, we have 8, 64, and then a big integer. Let's see how Spark behaves when ANSI mode is not enabled. So in this case, we are going to invoke the with column method to append a number plus 1 column. And we're just going to add 1 to the column, the number column. So we add 1 to the number column, and we can see that for the first 2 rows of data, everything is fine and dandy, right? So for 8 plus 1, we get 9. For 64 plus 1, we get 65. But for that big integer plus 1, we get an integer overflow. And obviously, we know Spark is constructed for large data sets. There can be billions of rows of data. We might not be able to spot when this integer overflow happens. So this is dangerous and bad. So all you need to do is enable ANSI mode, which is going to be enabled by default in Spark 4. And then when you run this computation, you're going to get this org Apache Spark arithmetic exception error, which is going to say, hey, this is arithmetic overflow. This computation is erroring out. We're not going to just silently give you junk data. Let's take another look at an example where ANSI mode saves you from some undesirable behavior. Let's suppose we have a data frame with two columns, num1 and num2. So those are just two integer columns. And then turn your attention to section 2. And ANSI mode is not enabled, and we are adding a column called quotient that will take num1 divided by num2. So again, for the first 2 rows of data, the quotient is computed accurately. But for the third row of data, we have 2 divided by 0, and that returns null. And that's bad because a number divided by 0 is undefined. It's not null. Null is incorrect and misleading. So when ANSI mode is enabled, we can see that this is going to error out with this Spark arithmetic exception divide by 0. So basically, when ANSI mode is enabled, you are going to have Spark that behaves in a safer manner. So you can generally just enable that and just enjoy the safer Spark. Okay, let's look at the variant data type, which is a new column data type that's useful in situations, in particular, when you're storing JSON data in a data frame. So this is pretty common that enterprises want to store JSON data in a column, and traditionally that's been stored in a string type column. And then you parse the JSON with this parse JSON method. Now that's fine and dandy, no problems, but it can be very slow. So what Spark 4 introduces is this variant data type, which is up to 8 times faster than storing JSON as a string. So it's pretty much the same behavior, but instead of storing JSON as a string type column, you can store it as a variant type column, and then you get this huge performance benefit. Okay, we are running through these amazing features. Let me actually just check the chat, see if there's any questions yet. Doesn't look like there are any, so we can keep going. Slideshow. Okay, now let's take a look at Spark Connect. So Spark Connect is a new Spark architecture that decouples the client and Spark server. So traditionally, the client and Spark server have been coupled, and now they're decoupled, which has a bunch of advantages. It has a couple disadvantages too, but it looks like this is going to be the default Spark mode in Spark 4. The community is still voting on that. So at a high level, how Spark Connect works is the client is responsible for constructing an unresolved logical plan, sending that unresolved logical plan to the Spark server, and the Spark server is responsible for running the query and then returning the results back to the client. So there are several advantages and disadvantages of this. We can't go into all of them, but the one I will be focusing on is how this feature allows for many new language implementations to be constructed that weren't really readily available in the past. So before we go into those, let's take a little bit of a deeper look into how Spark Connect works under the hood. So we have the client and Spark server, and they're establishing a connection via gRPC. So that's how the client and server are talking with each other. Then after that, the client is responsible for taking code in whatever language it may be in and converting that code to an unresolved logical plan. So that unresolved logical plan is then sent to the Spark server via protobuf. And what the Spark server is responsible for doing is taking that protobuf, decoding it, optimizing the query, executing the query, and then returning the query results back to the client. So this is what I mean by the decoupled nature of the client and the server. We can see they're talking to each other via gRPC, but they're not running on the same process. And the server returns the query results to the client via arrow record batches. So let's take a look at Spark Connect Rust, which is constructed with the Rust programming language and allows you to use Rust and execute queries with Spark. So we're just going to see an example of this in action just to see how it works. So in section 1 there, we are going to create a data frame using Rust code. So we're using spark.clone.sql, select apple as word, 1, 2, 3 as count. So that just creates a data frame with 1 row of data and 2 columns. And then we are going to write out that data frame to a Parquet file using save mode overwrite format Parquet, and we just write it out to a Parquet file on our local machine. And then in section 3 there, we are just going to display the results to make sure everything worked properly. We read in the Parquet file into a Spark data frame and then run the show method to just see that this is all working properly. So let's again think about how this is working conceptually. We have a library called Spark Connect Rust. Spark Connect Rust is responsible for taking this Rust code and converting it to an unresolved logical plan, sending that unresolved logical plan over to the Spark server, which does all the heavy lifting, and then receiving the results as arrow record batches. So that's how Spark Connect Rust is able to provide an end user interface in Rust, but also leverage the power of the Spark query engine and not do all that complicated, query optimization logic that Spark has to do under the hood. Let's take a look at another Spark Connect Rust example, just to kind of drive this lesson home even further. In this case, we're going to use Rust and Spark to convert a bunch of CSVs to a Delta table. So we read a bunch of CSVs into a Spark Connect Rust data frame. So as you can see, this Rust code is very Spark-like. It uses a Spark-like builder pattern, which is intentional. We want to give a familiar interface for users. So we construct this Spark Connect Rust data frame, and then we write it out to a Delta table. We can see we're setting the format to Delta, the save mode to override, and using save as table. And then we can just kind of read in this Delta table to make sure everything worked perfectly. And we can see it does. So this is really cool. And it's just another example of how Spark Connect enables us to build something like Spark Connect Rust, which is providing a Rust interface to write the code, but all the code underneath the hood is being executed as Spark. Let's look at another example that's leveraging this Spark Connect interface, which is Spark Connect Go. So in this case, I ran this on localhost. So I included the instructions on how to start the Spark Connect server locally. Remember that the server and the client are decoupled. So like unless you're using a service provider that has a Spark Connect server already spun up and you're connecting to that, you need to spin up your own Spark Connect server locally to run this code. Otherwise, you're just running the client and the client has nothing to talk to. So let's see how to create a data frame using Go and write it out to Parquet. So here we're using the same Spark SQL commands basically to create this data frame with 2 columns of data and 1 row of data. And we are writing it out to Parquet. But obviously, this is different from the previous example because this is using the Go programming language and not Rust. And then we are going to, again, read in the file and print the results just to make sure everything worked properly. And we can see that that worked perfectly. Now, one thing that's really cool about Spark Connect Go is that, for Rust, there's a bunch of high quality Rust data frame libraries like Data Fusion and Polars and Daft, for example. But the Go programming community doesn't really have any good data frame libraries. So Spark Connect Go is a great example of a very high quality data frame library for the Go community, and they don't really have access to any good data frame libraries. Let's look at one final Spark Connect based connector, which is awesome, which is this Sparkly R. This is allows the R community to access a very high quality Spark Connect connector. And you can use this by just loading in Sparkly R and dplyr. You can create a Sparkly R connection. In this case, we're connecting with Databricks, but you, of course, can do this with off of Databricks with open source Spark. And then in this case, we are reading in a Delta table that's registered in a Unity Catalog metastore and just printing out the results to make sure it all works properly. And this is really cool because you can use dplyr syntax, which is a popular R data frame library, to query a data frame using Sparkly R. So the dplyr community has a very passionate user base that really likes this kind of unique R syntax, and this gives them a great opportunity to use their R syntax and leverage the power of the Spark engine. Let's take a look at how to run Spark Connect locally in case you'd like to try it out for yourself. As we mentioned before, you need to start the Spark Connect server locally. You can run that by just invoking that shell script. That shell script is accessible if you download the Spark tarball on the Spark website. Now, one thing to note is that when you instantiate the Spark session, you have to use different syntax. So normally you just do spark session.builder.getterCreate, but in this case, you need to set remote equals to localhost to specify that, hey, this is Spark Connect. Actually, we're not using the Spark Classic mode. Once you do this, you can run most Spark code as you normally would. The syntax is generally the same, but there's a big caveat. A lot of Spark JVM code doesn't work with Spark Connect. There's a lot of features that aren't compatible. So sometimes you just need to make syntactic changes. Other times there's like actually major differences, and like the Spark Connect just won't run it. So that's a downside of Spark Connect. You can check out the Spark docs pages for a full list of all the advantages and disadvantages. I just really wanted to highlight those language connectors because I thought they were so cool. Here are some other language connectors that are in flight. We have SparkConnect.net and Spark Connect C#. They're both great projects. The authors are awesome, and they're taking contributions. So if you want to get involved and you like the .NET or C# ecosystem, definitely get involved. Okay, cool. Let's turn our attention to a new Spark feature in Spark 4. It's going to be really handy, especially in an interoperable scenario for tiny data sets. Unfortunately, I don't think this is going to be great for big data sets, but let's take a look at it. So we have this data frame toArrow method, which is going to be accessible for PySpark. And this returns the contents of a data frame as a PyArrow table. Now, that's really nice. So like, let's suppose you want to take a Spark data frame and then pass it off to Polars or DuckDB or another engine that's capable of reading PyArrow tables. So there's a lot of them. PyArrow is, of course, a great interoperability layer between different engines. In memory, of course, you could just write out files data to Parquet and then read it in, but that involves more overhead, disk I/O. That's not needed when you do an in-memory transfer. Now, the potential limitation of this is that PyArrow tables are materialized in memory, so I doubt that this is going to work for large data sets or be performant for large data sets. For larger data sets, PyArrow data sets are generally more efficient than PyArrow tables. But this should be a very useful tool if you'd like to convert between different engines for smaller data sets. All right, here's another support that's been built into Spark 4, which is XML support. Now, I've personally never needed to read an XML file in a Spark analysis, and I don't think XML is a good file format for large data sets. But this could be useful if you ever just have a random XML data set and would like to read it into Spark. we can see that similar to the native support of CSV and Parquet and Avro, Spark now has the ability to do spark.read .xml, and you can just natively read in an XML dataset. So that's kind of a cool new feature. Maybe it's not going to be the most used, but it's cool in niche applications. Cool. Let's take a look at a feature that's very widely used. This isn't technically Spark 4, but I just wanted to add this one in there because I think it's so cool, which are parameterized queries. So parameterized queries make it very easy to switch between the PySpark and SQL APIs, which is one of the powers of Spark. So let's take a look at this example here. We have this table with 9 rows of 9 columns and 3 rows of data. We're just showing 3 rows of data. Of course, there's many more. And what we'd like to do here is to parameterize this query such that it's easy for the user to run different queries with different ID1 values and kind of just invoke the same SQL query with different values. And when you look at this example, it looks similar to an F string, but we're going to talk about why it's different. So we construct this query over here in the top right, select ID1, sum V1 as V1 from the H2O 1E7 table, where ID1 equals the ID1 val. So the values that are in the curly braces are parameterized. So that's our parameterized value. And then we're grouping by ID1. Then when we invoke this query, we can see that we need to supply the parameterized value, which is ID1 val. And in this case, we're supplying the string ID016 and running the query. And we can see we just have our result, which is just 1 row of data. Then turn your attention to section 3. And we can see that we can invoke this query with a different parameter value very easily, right? We don't need to rewrite the query. We don't need to copy paste SQL. We can just change ID1 val to a different value, in this case, ID018, and get a different return value. Now, how this differs from F strings, right? So Python has F strings. Like, how are parameterized queries better than F strings? Well, first off, parameterized queries are sanitized, so they prevent from SQL injection attacks. Second off, the parameterized queries are intelligent. So if you have a Python value like a date, for example, like a Python date object, the parameterized queries can automatically convert those date objects into values that are understandable by the Spark SQL engine. And then third off, and this is my favorite one, if one of the parameterized value is a data frame, then Spark will, under the hood, automatically convert that data frame to a temporary view such that the query can be executed without forcing you to manually register the temporary view. Now, that's very handy and makes it seamless to switch between the data frame API and the SQL API. And that's actually my favorite feature of parameterized queries, because oftentimes, I start out with the PySpark API and go as far as I can. But then when it gets really crazy, I'll switch to the SQL API, and parameterized queries make that very easy. Okay, let's take a look at Python user-defined table functions. Again, there's a Spark 3.5 functionality, but it's not as well known. So this is talking about user-defined functions. So PySpark has long supported user-defined functions, but user-defined functions typically return scalar values. Scalar values are just like a single value, whereas user-defined table functions return multiple rows of data and multiple columns of data. So this is actually really powerful. We're going to see a contrived example, but this is actually a very powerful functionality in certain niche use cases. So let's see how to define this square numbers user-defined table function. So in section 1 there, we can see we have to use this UDTF annotation and explain the return type. The return type is the schema that will be returned. So we have a num column, which is of integer type, and a squared column, which is also of integer type. Then we have to define a class with an eval method. The eval method can take arguments. In this case, we're taking the start and end values. And it's going to loop over all of these values and return the number and the squared value of the number. So after we define that code, we need to register this user-defined table function. In this case, we're registering this function, naming it square numbers, and saying that it's attributable to this class, square numbers. And let's take a look at how we can invoke this user-defined table function. So here we do spark.sql, select all from square numbers, 1, 4. So we're invoking square numbers with 2 arguments, 1 and 4. And then we can see that the functionality is to go from numbers 1, 2, 3, and 4, and then return the square of that value. So again, the critical difference between a user-defined function and a user-defined table function is that a user-defined function returns a single scalar value, whereas a user-defined table function returns a table of values. Niche functionality, but very powerful. Cool. Last little example here are hyperlog log sketches. So again, this is a Spark 3.5 functionality that I think is even more obscure and less well known. Hyperlog logs are very powerful representations for computing the count distinct. Computing count distincts is a very expensive operation. Now, kind of the magical property of a hyperlog log is that they're reaggregatable. Can't go into all the details here, but basically for the count distinct operations that Spark uses, it's always used these hyperlog logs under the hood. And the key difference now is that it's exposing the actual sketches, which is very useful in if you're using a count distinct sort of operation and you don't need it to be 100% accurate. So I want to leave a couple of minutes just in case there's questions. But basically, as you can see in this example, just really quickly, you can use this HLL sketch ag function to actually return the hyperlog log sketch itself. And that could be persisted in storage, and those can be reaggregated. Cool. I will stop there. If you like this content, you can feel free to follow me on LinkedIn. This is the sort of content I generally churn out. And thank you for coming.
All right, we have about a minute left. If there are any last minute questions, you can use the Q&A tab on the right-hand side. I think it's safe to say we're good to go. But if there are any other questions, feel free to use our PyData Discord channel where you can chat with your fellow attendees. We also have our lounge that's accessible through AirMeet. But a big thank you, Matthew, for this presentation and for being here today. And thank you for everyone who joined. I'm going to go ahead and end this session, but I hope you all have a great rest of your day.
Thank you. Bye.